Get ready for a cloud-first workplace. Jumpstart your career by signing up for a Google Cloud hands-on learning experience. Companies around the world are moving to the cloud. This is a unique opportunity to gain new skills and professional credentials. If you want to discover a career, scale your startup, or perform groundbreaking research that will change the world, this is the event for you.
Hey everyone! Hello and welcome to a brand new session of Google Cloud Online Study Jam. I'm Parvez and a customer engineer for Google Cloud. In today's session, I'm very excited to take you on a journey of learning some key concepts on cloud and show you how you can implement them on Google Cloud Platform. With that, let's take a quick look at the agenda. We'll start off by discussing some of the generic cloud concepts. This will help us understand the basics of cloud and also set the foundation for some of the labs that we'll be covering in later part of the session. With most of the companies moving towards cloud, having a deeper understanding of cloud domain can help you grow your career and offer you with that key competitive advantage. We'll discuss Google Cloud Career Readiness program and understand how you can make the best use of the platform that Google is offering to ensure you are a cloud champion. We'll also do some labs together and get quick hands on experience on some of GCP's state of the art products and services through quick labs. This will help you earn badges and unlock some deeper learning capabilities as well. Finally, I'll show you how to make your quick labs profile public and showcase your achievements. With that, let's get started. So, what is cloud? Cloud is a platform that provides on demand availability of resources for all your computational needs, be it machine learning, AI, data analytics, or application development. Cloud is a one stop solution for all your business requirements. Your next question could be, why is it so important? And what's even possible with cloud? Pay attention as this is critical in understanding cloud computing. Cloud is important for three main reasons. A. Cloud ensures your applications can scale and meet the demand of your customers in no time. For example, imagine you're the owner of a shopping website and you have deployed the application on one of your servers at home. Now, all of a sudden, you see a sudden surge in traffic. Since your goal is to cater to as many customers as possible, you go out and purchase additional servers, deploy your application on these servers, and cater to your customers. But the next day, what if this traffic increases further? You will have to invest a lot of money once again in purchasing additional hardware and keep in mind the time lost in setting it up and deploying your application. Also, what if the traffic drops? What do you do with the additional servers that you just purchased? This is where cloud comes into picture. Cloud helps you scale at the pace that you need. Need more servers? Few clicks of a button and you have multiple servers available and in no time. Second reason cloud is important is because it ensures applications are highly available. There might be instances where your application comes crashing down or your data is lost, or there could even be a natural disaster like earthquake or floods in some part of the world where your application is present. How do you ensure business continuity in such scenarios? Cloud services offer high availability, ensuring fault tolerant and redundant systems. Lastly, and most important of all, it allows you to focus your energy in designing solutions and solving business problems rather than focusing on your infrastructure needs. Let's take a look at a real world example that we all are likely familiar with. How many of you have played Pokemon Go or know someone who was a huge fan of the game? Pokemon Go is a mobile application that uses many services across Google Cloud. When the game launched, the teams targeted 1x player traffic with a worst case estimate of roughly 5x this target. The game's popularity caused the traffic to surge so rapidly that the player traffic reached 50x the initial target. It is 10 times the worst case estimate. But that's where GCP comes into picture. The application was able to scale and meet the demand with the reliability and scalability provided by Google Cloud services such as Google Kubernetes Engine, HTTP load balancing, and Google Cloud Data Store. Don't worry if you don't know what these products are. We'll learn about some of these Google Cloud services in the later part of the session. Now that you're familiar with cloud and its importance, let's try and understand the different types of cloud based services that are available. There are three main types of cloud based services: infrastructure as a service, platform as a service, and software as a service. Let's take a look at it one by one. With infrastructure as a service, you don't invest in hardware. Infrastructure as a service includes raw resources such as virtual machine, networking, storage, and many others made available to you directly. These resources act as the fundamental building blocks of cloud computing. When you consume infrastructure as a service, you have greater control over the resources, but also greater management overhead. Virtual machine is a great example of infrastructure as a service. With virtual machines, you have greater control over the softwares you need to install, and hence any upgrades or patching of the server will also have to be done by you. The best part, you can configure your virtual machines to scale based on the load of your application. Google Compute Engine, networking, and load balancers are great examples of infrastructure as a service. Now, platform as a service, on the other hand, provides a platform with managed services where runtime environment and network settings are all pre configured. This makes it easier for you to develop and deploy your application. Google App Engine is a great example of platform as a service. App Engine comes pre configured with runtimes for Java, Python, Node, and many more. Software upgrades and patches are all automatically applied. Load balancing is also pre configured. So, no investment in hardware, no installing, upgrading, or patching of software. With platform as a service, you just focus in designing and developing the application logic. So, how is it different from infrastructure as a service? With infrastructure as a service, you are responsible for operations like maintenance, upgrading, and patching, whereas with platform as a service, cloud service providers ensure that. Lastly, with software as a service, the entire application is managed and made available in a cloud environment. Gmail is a great example of software as a service. You don't have to worry about the infrastructure it is hosted in. You don't have to worry about the application code. You just consume the service. Now that you have uncovered some of the basics of cloud, let's put all of it to use with Google Cloud. Imagine you are designing an online game. What are some of the products and services you can use on GCP to solve this problem? You can use Google Cloud services to store object data such as image and video files in Google Cloud Storage. You can store high volume or semi structured data such as streaming or game data in a NoSQL database like Firestore or Bigtable. You can also store relational data pertaining to users such as user ID and so on in traditional relational databases like MySQL or Spanner. For your application to execute, there are multiple options such as Kubernetes engine or virtual machines. You can also build apps which use other services like Google Maps and YouTube. You see, with cloud based services, you don't have to set up and manage your own infrastructure. You can simply focus in designing and developing your app and then use managed cloud services to make it available globally in just a few minutes. Congratulations on making it so far. With a strong foundation in cloud, we are now ready to unlock some amazing opportunities and introduce you to the Google Cloud Career Readiness program. Let's take a look at this short video.
Cloud computing has transformed how businesses scale, innovate, and even hire. From startups to established companies, there is a growing need for cloud-ready professionals in any workplace. The Google Cloud Career Readiness program helps you prepare for a cloud-first workplace by making you ready for industry-recognized certifications. With on-demand training on Coursera and Quick Labs, you will build skills in topics related to cloud infrastructure, data analytics, and machine learning. After completing the certification exam, you will get access to digital badges and credentials, which will help you build your resume and unlock new job opportunities. Institutions around the world have partnered with Google Cloud to solve for student success. Apply for the Career Readiness track and help transform the future.
Welcome back. Wasn't that exciting? As I mentioned previously, cloud is a booming technology. IT companies across the globe are shifting their traditional infrastructure to cloud. This shift is generating a higher demand for cloud engineers as well. Now, using the resources which I'll be sharing with you, you can learn about GCP services and become eligible for such positions. As you navigate through your university, you will be exposed to a lot of technologies, which is fantastic. This is the first step, and you're heading in the right direction. But in order to launch your career, you need to have certain industry skills. Bridging the gap between industry and curriculum is the goal of Career Readiness program. So, how do we get started? First, make sure to complete all the labs in Google Cloud Essential Quest and get your badge. These labs are available at google.quicklabs.com. Badges unlock deeper learning benefits. You're already doing this by attending the event today. You can then go on to build your cloud muscle with the Google Cloud Career Readiness program. The program offers in depth training on Coursera and Quick Labs. On successful completion of the training, you will receive a course completion certificate from Google Cloud and Coursera. With Cloud Study Jams and the Career Readiness program, your learning journey with Google Cloud sets you up strongly for competitions and internships or your first job. There are multiple resources offered by Google for free to make you successful. Let's take a look at it one by one. Coursera offers a great mix of slides, labs, and quizzes. This accelerated specialization is designed to be completed in only 4 weeks. When you finish every course and complete the hands on project, you'll earn a Coursera coursework completion certificate that you can share with prospective employers and faculty within your professional network. We also have Quick Labs. In Quick Labs, we give you temporary credentials to Google Cloud Platform so that you can learn using the real thing. No simulations or demo environment. In Cloud Architecture Quest, the labs have been curated to give IT professionals hands on practice with topics and services that appear in the Google Cloud Associate Cloud Engineer certification. Finally, you can start working towards your Associate Cloud Engineer certification. Certifications are a great way to prove to your employer about the skills that you possess in a particular domain. Our certification exams must be taken in person at a criterion testing center. All right, it's now time to introduce you to a hands on learning platform, Quick Labs. Don't worry, I'll help you set up your Quick Labs account if you don't have one already. First, let's go ahead and launch an incognito window. Incognito window makes it easier for you to understand the whole process from scratch. Now go ahead and launch google.quicklabs.com. If this is the first time you're hearing about Quick Labs and don't have an account yet, then just click on join and create one now. You can use your Google account as well to sign up. Do remember to check in the marketing option when creating a new account. This makes you eligible for additional free access after you complete the quest today. If you already have an account, great. Just click on sign in and log in. Next, go to your inbox and find an email with the subject line Google Cloud Online Study Jam. This email contains a bit.ly URL that will directly take you to the landing page of Google Cloud Essentials Quest. Copy this URL and paste it in the incognito window that you just used to open your Quick Labs account. Just a quick note to avoid any confusion, make sure to only use the URL given in your inbox. This will help you in receiving your Quick Labs credits. This is what you should see. Click on Enroll in this quest button. You should now see the 5 labs listed in the quest. We will go through each one of them in this session. All right, then. You're all set to take part in the hands on lab experience now. As discussed previously, today we will be going through the Google Cloud Essentials Quest, one of the foundational quests on Quick Labs that will help you get started with GCP. Remember, you need credits to take these labs. By completing the first lab, you will earn 50 credits. You can then use these credits to complete other labs. All right, then, let's start exploring what a first lab is all about. Our first lab is intended to give you a quick tour of Quick Labs environment and introduce you to some super important concepts on Google Cloud Platform. In the next few slides, I'll explain these concepts in detail. First, let's understand what a project is all about on GCP. Think of a project as a virtual boundary within which all your computations are performed. By computation, I mean the space where you launch GCP's products and services to accomplish your business requirements. Every resource that you launch on Google Cloud Platform is associated with a project. A resource could be a virtual machine, a MySQL database, a BigQuery data warehouse, or any other product or service on GCP. Let me give you a simple analogy. If you were to build your own house from scratch, the walls surrounding your house would be defined as a project. Everything within this house, you could have either a television set, a lounge, a coffee maker. All these are nothing but your resources on GCP. All clear? All right. There are 4 primary objectives of a project: A, to track resource and quota usage, B, to enable billing, C, to manage permissions and credentials, and D, to enable services and APIs. With that, let me summarize. Any resource that you use on GCP should be associated with the project. You can have more than one resources within the same project as well. Moving on, let's now understand how identity and access management functions within GCP. Security is core to every organization. So, how do you ensure that the resource you just created on GCP console is accessible to only authorized users and not accessible to any unauthorized user? This is where GCP identity and access management comes into picture. There are 3 things you need to understand to define identity and access management permissions. First, the who part. Who is the user or group that needs access? Second, the can do what part. This defines the level of permission that will be assigned. Always remember, follow the principle of least privileges. Never assign or grant irrelevant or additional permissions to any user. You don't want your database developer to be able to stop and start a web server in your project. Most of the time, to do any meaningful operations, you need more than one permission. For example, to manage instances in a project, you need to create, delete, start, and stop an instance. So the permissions are all grouped together into a role. This makes it easier to manage. An IAM role is nothing but a collection of permissions. For example, compute admin is a role that has full control over compute resources like virtual machines. So, a question for you. If a user were to need permission on BigQuery data warehouse, would you grant them compute admin role? Think about it. Finally, the last component is the resource part. You grant relevant access to users on a particular resource. Remember, only grant required permissions by following the principle of least privileges. With that, it's now time to launch our first lab. Welcome to our lab. The goal of this lab is to introduce you to Quick Labs platform and Google Cloud Console. First things first, make sure you have opened this page in an incognito window. Now, let's get to know some of the features that Quick Labs offers. Each lab comes with a detailed set of instructions at the top of the page. Make sure you read them thoroughly before you start the lab. The navigation pane to your right indicates specific goals and objectives that are designed for this lab. Most of the labs also provide a score to track your lab completion. Once you are ready to launch the lab, click on the Start Lab button present to your upper left. This creates temporary credentials with which you can access Google Cloud Console. The time mentioned next to the Start Lab button indicates the time allotted for this lab. Make sure to complete this lab before your time runs out or you will lose all your hard work. Also, the temporary credentials allotted to you for this lab will also get destroyed once your time runs out. With that, let's go ahead and start our first lab by clicking on Start Lab button. As you can see, temporary credentials have been created. These credentials will be used to access the GCP console. Once you click on Open Google Console, you will be taken to a sign-in page and requested to enter your credentials. Please do not enter your personal account details or any other credentials here. Go back to Quick Labs and copy the username that was generated for you. Next, you will be asked to enter the password. Use the same password provided in the Quick Labs window. In the next window, click Accept to indicate your acknowledgement of Google's terms of service and privacy policy. You will now be asked to update your phone number and email ID. Ignore this part since this is just a temporary account. And with that, welcome to Google Cloud Platform. You will be asked to select the country you're based in and agree to the terms and conditions. Indicate your acknowledgement of Google's terms of service and privacy policy and hit Agree and Continue. The page that you see on your screen right now is your home page. If you observe to the left, the first thing to note over here is that a project has already been created for you. This is the same project ID that was listed in the Quick Labs page as well. Three things that are important to understand over here: the project name, the project ID, and the project number. Let us understand them one by one. When you create a project, you will also assign a project name to it. During the project creation process, you also assign a project ID to it. Now, the project ID is a unique ID that will be used by Google APIs. If you do not specify a project ID during project creation, a project ID will be automatically generated for you. Now, a project number, on the other hand, is an automatically generated unique identifier for your project. With that, let me now show you how to navigate within the GCP console. The navigation menu placed on the upper left section will show you all the GCP products and services that are available. The menu is subdivided into several categories. Compute section offers a variety of machine types. We'll go through compute in detail in the next lab demo. Storage section offers multiple products for all your data storage needs. Similarly, we have multiple products offered under networking, big data, and artificial intelligence as well. I highly recommend navigating through the product catalog to make yourself comfortable. Next, let us take a look at identity and access management. Go to the navigation menu and select IAM under IAM and admin section. Here you will see that the account with which you logged in has been granted editor and viewer permission. Now, editor, viewer, and owner permissions fall under the category of primitive roles on GCP. As a viewer, you will not be allowed to make any changes or updates. As an editor, you have viewer access, plus you can make changes to the resources for which you are assigned this permission. As an owner, you have editor and viewer permissions, and along with this, you can manage permissions and resources within your project as well. Now, let us take a look at the APIs and services section. Go back to the navigation menu and click on APIs and services. API stands for Application Programming Interface. Google Cloud offers multiple APIs to help programmers make use of the services on GCP and call them directly via application code or via client libraries. Under the library section, just search for the API that you need and enable it. Once you enable the API, go through the documentation section and understand the function calls that the API accepts. In the last section of this lab, let us take a look at Cloud Shell. Now, Google Cloud Shell is an interactive shell environment for Google Cloud Platform that makes it easy for you to manage your projects and resources from your web browser. In order to activate Cloud Shell, just click on the Cloud Shell icon present over here. You will see that a new window has opened up at the bottom of the page. This new window is Cloud Shell. We'll go ahead and run a few commands to make ourselves familiar with it. The first command that I'll be running is gcloud auth list. This command shows which account is live. Note that this is the same account that I used to log into the GCP console via Quick Labs. We'll now go ahead and create a simple file called file.txt using the touch command. Use the ls command to list the file that you just created. Using the nano editor, we'll go ahead and add some content within this file as well. Use Ctrl X command followed by Y to save the file and hit enter to exit. Now to see if the changes we made have been reflected, we'll use the cat command. And there you go. Simple and easy to use. That marks the end of this lab. Go back to Quick Labs now and complete the set of questions that are present under each section. Once you're done, click on End Lab now to end the session. Don't forget to give yourself a pat on the back for completing the first lab successfully. Congratulations. Congratulations on completion of your first lab. You should now see 50 or 50 plus credits in your profile. Don't worry if you don't see any credits. I'll show you a few troubleshooting tips in the next slide to help you get the credits. If you face any issue on the Quick Labs platform, such as an account block or quota reset of lab session, or you did not receive the credits, please reach out to Quick Labs support team via email, which is support@quicklabs.com. You can also launch a chat session from within the platform with Quick Labs support team for faster resolution as well. All right then, it's time now for a second lab. In a second lab, you will learn how to create a virtual machine, install a plain vanilla Nginx server in a particular location. But before that, let's understand the concepts involved in this lab. Regions and zones. Any resource that you launch within a project has to be assigned a location. A region is that specific location where you launch your resources. Think of regions as independent geographic areas on the world map. When this video was launched, Google had its presence across 24 regions all over the world. A zone, on the other hand, is an isolated location within a region. You can think of it as being similar to a data center. Always remember, a region is a collection of zones. For example, US West 1 is a region. US East 1 is a region. But within US West 1, you can have multiple zones like US West 1A, West 1B, and West 1C, and similarly within US East 1 as well. So why is this important? In the rare case that one zone goes down, the other zones will still be operational. A zone is designed and set up to be independent of the other zones within a region. Remember, we discussed about high availability and reliability in previous slides. To enable fault tolerance with high availability, you should deploy your applications across multiple zones. For example, if a zone is affected by a network outage, your application will still continue to function if it is deployed across multiple zones. Moving on, let's now understand more about a virtual machine. You've likely worked with a physical computer before. A physical computer has resources such as CPUs, memory, disk storage, network configuration, operating system, and other application softwares. A virtual machine, on the other hand, is a software based computer, but just like a physical computer, it also has resources like CPU, memory, operating system, etc. A virtual machine uses the physical resources of the host that it is running on. Every virtual machine has virtual devices that provide the same functionality as physical hardware. They also have additional benefits related to portability, manageability, and security. For example, you can launch a virtual machine, run applications for some time, and then destroy the virtual machine when the resources are no longer needed. Google offers virtual machine through a product called Compute Engine. Compute Engine offers several virtual machines with predefined machine types. You can also configure a custom virtual machine with your own CPU, memory, and disk specifications. You can also select the operating system that you would like to install on this virtual machine. Hands on experience with the lab will give you a much better idea. Let's get started. Welcome to our second lab environment. The goal of this lab is to show you how simple and easy it is to create a virtual machine on Google Cloud Platform. We will learn how to use both the console and the Cloud Shell to create a virtual machine. We'll also deploy a simple web server on this machine and connect to it. First, as you did in the previous lab, read the instructions thoroughly. In order to complete this lab, make sure you track your progress with the score listed on the upper right side of the page. Once you complete a section of the lab, come back to this page and use the Check My Progress button to update the score on the page. With that, let's go ahead and start the lab. You will once again use Quick Lab credentials to sign into GCP console. Use the password that is provided over here. Now go ahead and indicate your acknowledgement of Google's terms of service and privacy policy by clicking on Agree and Continue. Alright, looks like a home page is loaded. Now as a first step, we will go ahead and activate Cloud Shell as we'll need this for later part of the session. While this is getting initialized, let me show you how you can navigate to the virtual machines section on the GCP console. All you need to do is go to the navigation menu, click on Compute Engine, and select VM instances. I'll go ahead and minimize the Cloud Shell. To launch a new virtual machine, click on Create. On this page, enter the details of the virtual machine that you plan to launch. If you go back to Quick Labs page, you will find the details that you need to enter over here. I'll change the name of the instance to GCE Lab. Remember, every resource on GCP needs to be placed in a particular region. For this lab, we'll select US Central 1 as the region and US Central 1C as the zone. Now there are multiple machine types available that you can choose from. For this lab, I'll go ahead and select N1 Standard 2. N1 Standard 2 machine type comes with 2 cores and 7.5 GB of memory. For the operating system image, under boot type, change this to Debian stretch mode. Note that this comes attached with a 10 GB persistent disk as well. Leave the identity and API access as default. Under the firewall section, allow HTTP traffic. Right, with that, go ahead and hit create. While this is initializing the instance, let's talk a little bit about the firewall section. Now, firewall rules are important to secure your environment thoroughly. Note that HTTP works on port 80. So, by checking the allow HTTP traffic box, you are indicating that any request that comes in at port 80 should be granted access. However, if you receive a request on any other port, access should not be granted. With that, looks like a VM instance just got created. Our next goal is to connect to this virtual machine and install an Nginx server. We will be using SSH for this. Click on SSH against the virtual machine that you just created. Now, what is SSH? SSH is a protocol which allows you to connect securely to a remote computer or a server by using a text-based interface. Let's give it a few seconds for it to initialize. Okay, now that our window is active, let's switch to the root using the sudo command. Okay, let's quickly go ahead and update our operating system as well. All right, looks like everything is ready. We'll now go ahead and install a plain vanilla Nginx server. Give it a few seconds to install. Once it's done, you can check for the status using the following command. Perfect. Looks like we're good to go. So, summarizing what we have done so far, we created a virtual machine, we used SSH to connect to it, and we also installed the Nginx server. Now, in order to access the default web page of the Nginx server that we just created, you will need the external IP. So, what is an external IP? Every domain name that you enter in your browser has an external IP associated with it. In our case, since we don't have a domain name or a host name, we'll just use the external IP directly. And there you go. You just created a virtual machine and installed a web server successfully in no time. Now, for the second part of the lab, we will create a virtual machine using Cloud Shell directly. Go back to GCP console and open the Cloud Shell. I'll directly use the command that has been provided on the Quick Labs page. So, what does this command actually do? As you can see, the command contains the machine name, machine type, and the region I want it to be launched in. So I'll go ahead and hit enter. Right, we'll give it a few seconds to initialize again. And perfect. Looks like a machine or a VM instance has been initialized and created. I'll go ahead and refresh the browser to see the virtual machine on my console as well. And there you go. GC's Lab 2 is the machine that we just created. With that, this lab is successfully over. You see how simple and easy it is to launch a virtual machine in a matter of seconds. That's the power of Google Cloud Platform. Now don't forget to go back to Quick Labs page and track your progress. If everything looks good and your scores have been updated, click on End Lab to close the session. Good luck. Congratulations on completing your second lab. In a third lab, you will be introduced to Google Cloud Shell and how you can connect with resources hosted on Google Cloud Platform. Cloud Shell provides us with command line access to all our cloud resources directly from the browser. You can easily manage your projects and resources without having to install the Google Cloud SDK or any other tools on your system. Just log into Google Cloud Console and simply launch the Cloud Shell. With Cloud Shell, the Cloud SDK, gcloud command line tool, and other utilities you need are always available, up to date, and fully authenticated when you need them. Cloud Shell allows you to manage your GCP resources with the flexibility of a Linux shell. It comes with 5 GB of persistent disk storage as well. Lastly, it provides command line access to a virtual machine instance. Let's understand this more in the lab environment. Welcome to Lab 3. The goal of this lab is to help you get comfortable with the Cloud Shell environment. Throughout this lab, we'll be practicing some of the commands that are very commonly used. Now, using the Quick Labs credentials, I've already logged into my GCP console. As the first step, let's go ahead and activate the Cloud Shell by clicking on the Activate Cloud Shell icon. Click on Continue and give it a few seconds for it to create and initialize a Cloud Shell environment. Now, first things first, to verify the account that is currently live, use the gcloud auth list command. The account listed over here should be the same account with which you logged in to the GCP console. With that, let's learn a little bit more about the gcloud command line interface. The gcloud command line interface that we are using over here is a part of Google Cloud SDK. So you might have the following question. Can I use the gcloud command line interface from my machine directly? And that too without having to log in to my GCP console? And the answer is yes, you can. But for that, you need to download and install the Google Cloud SDK on your system first. You will then have to initialize gcloud command line tool by running gcloud init to initialize it. But since we're using Cloud Shell, all of this is taken care of. So nothing to install and nothing to initialize. Moving on, sometimes as an administrator, for the ease of usage, you would want to select a default region and zone. To know which region and zone have been marked as default, we will use the gcloud compute project info describe command. This command displays all data associated with the Google Compute Engine project resource. As you can see, I have appended the project ID at the end of the command. How do you find out the project ID? You can either find it on the home page of GCP console right over here, or for this lab on the Quick Labs window. In the output, look for Google Compute default zone and Google Compute default region. As you can see, US Central 1A has been marked as the default zone and US Central 1 has been marked as the default region. To change this setting, we will use gcloud config set command. We will now change the default zone to US Central 1B. And there you go. The property has now been updated. Moving on, let's take a quick look at the environment variables within Cloud Shell. Environment variables come in very handy when you're writing scripts that need some data to be repeated again and again. So how do we do that? We do that using a simple export command. For example, if I had to set up an environment variable for zone, we will use the following command. Please feel free to change the name of the variable. Just for easy understanding, I'm naming it as zone variable. As you can see, I have assigned it a value of US Central 1C. Go ahead and hit enter. Just to ensure you have the right values in, you can use the echo command. And that looks good. Now let us go ahead and create a simple virtual machine using Cloud Shell. This is the same command that we used in our last lab as well, except for one small change. Instead of providing the actual zone, we'll be replacing it with the environment variable that we just created. As you can see, I have replaced the actual zone value with the environment variable that we just created. Hit enter and give it a few seconds for it to create and initialize the virtual machine. Alright, now that you have created a virtual machine, if you are stuck at any stage and need help, you can use the gcloud -h command. If you observe here, gcloud commands are divided into several groups. Compute is also a group. Since we just created a virtual machine and virtual machines fall under the category of compute, let us run gcloud compute -h command. Observe that compute is also subdivided into several groups. Now, to get more detailed information on every attribute, you can use gcloud compute and follow it up with the help command. You can hit enter to read through the entire documentation. But if you have to exit the documentation, just hit Q. Now, if you're wondering if you need to memorize all these commands, you don't have to. Cloud Shell offers auto-completion feature that helps you in completing these commands. Let's take a look at how you can activate it. When this video was published, this feature was in beta. So let's go ahead and install the beta component first. Give it a few seconds for it to install. Once installed, we will use gcloud beta interactive command to enter the interactive mode. Give it a quick second for it to initialize. Now that this is active, let's go ahead and try out a very simple command. If you observe, as soon as I typed gcl, it gave me an option to enter gcloud. Similarly, if I type in com, it gives me an option to either type in components, composer, or compute. Simple and very easy to use. And that marks the end of this lab. Please feel free to play around with Cloud Shell and use it to connect to your VM instance using SSH as well. Make sure you go back to Quick Labs page and complete the lab within the time allotted. Good luck. Congratulations on completing your third lab and welcome back. We are down to our last two labs now. In our fourth lab, we will learn how to create a Kubernetes cluster and how you can deploy a simple application to the cluster. Before that, let us understand what containers and Kubernetes is all about. Have you ever encountered an issue where the application that you developed works great in your laptop but fails when you deploy it on your friend's laptop? This happens a lot in industries as well. Most of the organizations have multiple environments like development, testing, and production. A production environment is the one that is live and serves to the end customers. Inconsistencies in the development and production environments can result in your application working well in your development environment but failing to deploy or run optimally in your testing and production environments. For example, your local development environment might be running Nginx 1.15 and SQLite, but your test and production environments might be running Nginx zero point 0.4 and MySQL. Even if all the environments are running the same type of software, there might be different versions of the same software. Errors caused by differences in the environment can be difficult and time consuming to troubleshoot. The inconsistencies affect the overall reliability of your application releases as well. To resolve this problem, containers are used. A container image for your application is a complete package that contains the application binary and all the software that is required for the application to run. When you deploy the same container image on your development, test, and production environments, you can be assured that your application will perform exactly the same way in each of these environments. Container registry is nothing but a private repository for your Docker container images. In order to understand Google Kubernetes engine, let us first understand what Kubernetes is all about. Kubernetes is an open source container orchestration system for automating computer application development, scaling, and management. Kubernetes objects represent your containerized applications and run on top of a cluster. Your next question is, what is a Kubernetes cluster? A Kubernetes cluster is an environment that consists of at least one cluster master machine and multiple worker machines called nodes. A master node is a node which controls and manages a set of worker nodes. Nodes are nothing but compute engine virtual machines that run the Kubernetes processes within a cluster. With that, let me introduce you to Google Kubernetes Engine. Google Kubernetes Engine is a managed service for Kubernetes. Google Kubernetes Engine enables rapid application development and iteration by making it easy to deploy, update, and manage your applications and services. Let me take you to the lab and showcase how simple and easy it is to use Google Kubernetes Engine. Welcome to Lab 4. In this lab, we'll learn how to create a Kubernetes cluster and deploy a simple application to it. As you can see, I've already logged into my GCP console using my Quick Labs credentials. Make sure you sign into GCP console only using the credentials present on the Quick Labs page. You can take a look at Lab 1 and 2 if you need help with this step. With that, our first goal is to create a Kubernetes cluster. You can launch Kubernetes cluster using the console UI as well, but for this lab, we'll use Cloud Shell. As a first step, let's go ahead and activate Cloud Shell. Give it a few seconds for it to initialize. Now, first things first, make sure you're using the right account. We'll use the gcloud auth list command to verify this. Ensure that this is the same account you use to log into GCP console as well. Now, usually in an organization, you'll be working with multiple projects. Within Cloud Shell, you would want to make sure that you're located under the right project before making any changes to it. We'll verify this using the gcloud config list project command. Alright, now that our preliminary checks are complete, let's go ahead and set a default zone for our clusters to run in. For that, we'll use gcloud config set command. As you can see, I've set US Central 1A to be my default compute zone. And it's time now to create a first cluster. For that, we'll be using the following gcloud command. I've appended the name of my cluster at the end of the command. Okay, I'll go ahead and hit enter. Now all these commands have been listed on your Quick Labs page as well, so please feel free to copy and paste them in your Cloud Shell. Give it a few seconds for it to initialize the cluster. But while this is happening, let's learn a little bit more about what's happening in the background. As we've already learned in the previous slides, Kubernetes cluster is a collection of nodes which are nothing but Google Compute virtual machines. While the cluster is being provisioned, the nodes are also getting created. Ideally, you'll have multiple nodes within a cluster, but for this example, we'll be running a 3-node cluster. Now that our cluster has been created, let's go to virtual machines section and take a look at the nodes that have been provisioned as part of a Kubernetes cluster. So go to the navigation menu. Within Compute Engine, go to VM instances. As you can see, these are the nodes that have been provisioned as part of a Kubernetes cluster. With that, it's time now to go ahead and deploy a simple application to the Kubernetes cluster that we just created. But first, you will need authentication credentials to access this cluster. Let's go ahead and run the following command that will help us in fetching the credentials. As you can see, the name of my cluster is my cluster. You can give it a good name as well. Now, next step, let's go ahead and deploy our application. For this, we'll be using the kubectl create deployment command. Now, the image property that you see over here in this command is nothing but the container image that we'll be deploying. This is a public container available on the Google Cloud repository, right? I'll go ahead and hit enter. Since this is a 3-node cluster, we'll go ahead and create a load balancer to it as well. This will help us balance the traffic between the 3 nodes. You'll learn more about load balancers in your next lab. For now, go ahead and run this command. As you can see, our load balancer accepts traffic at port 8080. To make sure the load balancer service that you just created is up and running, use the kubectl get service command. Now, interesting thing to note over here is that the external IP is currently in pending stage, which means it is still getting provision. So give it a few more seconds and we'll run this command again. And if you recall in lab 2, we use the external IP to access our application. We'll do the same thing over here as well. I'll go ahead and run the same command again. And there you go. Looks like our external IP is now ready to be used. Now that our external IP has been provisioned, I'll just copy and paste it in the browser using port 8080. And as you can see, we are now able to successfully access our application that we just deployed within a Kubernetes cluster. Now, in order to complete this lab, we'll have to delete a cluster as well. But before you do that, go back to Quick Labs page and make sure to click on Check My Progress button. This is present just before the cleanup section on your Quick Labs page. And if you're good to go ahead and delete the cluster. For that, we'll use a simple gcloud command. I use gcloud container clusters, delete, follow it up with your cluster name. Hit yes, and your cluster will get deleted in a few seconds. And that marks the end of this lab. Congratulations once again. Go ahead and watch the last section of this video and complete the Google Cloud Essentials quest. Good luck. Welcome back. Keep your spirits high as we now enter into the last and final lab of this quest. In this lab, we'll discuss different load balancing options that GCP offers. Before that, let us understand the concepts. Imagine you're the owner of an online shopping website that has announced a 3-hour sale between 6 p.m. and 9 p.m. on a particular day. You are currently running this website on a single server. Thousands of customers all hit the website at 6 p.m. to take advantage of the sale. The website starts off well but soon becomes unresponsive. Heavy volume and sudden spikes in traffic can cause your servers to become overloaded and run out of resources such as memory. How do you overcome this problem? You use load balancing techniques. Load balancing is the process of distributing network traffic across multiple servers. This ensures a single server is not overloaded by heavy demand for your application. By spreading the incoming requests evenly across multiple servers, load balancing improves the responsiveness and reliability of your application. Let us quickly take a look at the lab demo. Welcome to Lab 5. In this lab, we'll learn how simple and easy it is to create load balancers on GCP. As we discussed in a previous slide, a load balancer distributes user traffic across multiple instances of your application. Now, there are different types of load balancers available on GCP. As part of this lab, we'll learn how to set up a network load balancer and a HTTP load balancer. We'll also learn the differences between these two load balancers. To make it organized, the lab is divided into three main sections. In the first section of the lab, we'll create a web servers that will be placed behind the load balancer. In the second section, we'll create a network load balancer. And in the last section, we'll create an HTTP load balancer. With that, let's get started. As you can see, I've already logged into my GCP console using the credentials available on my Quick Labs page. Make sure you sign into the GCP console only using the credentials present on the Quick Labs page. You can take a look at Lab 1 and 2 if you need help with this step. Now, load balancing can be set up using both the console and Cloud Shell environment. For this lab, we'll be using the Cloud Shell environment. As a first step, let's go ahead and activate our Cloud Shell. Let's go ahead and run a preliminary checks to ensure we have the right account and right project set. Alright, that looks good. Let's now go ahead and set a default region and zone as well. I have discussed these steps in Lab 4. Please feel free to go back to Lab 4 in case you need more detailed information. As you can see, I have marked US Central 1 to be the default region and US Central 1A to be the default zone. With that, our first step is to create web servers that will be placed behind the load balancer. To accomplish this, we'll create a simple cluster of Nginx web servers to serve static content using instance templates and managed instance groups. So what is an instance template? Instance templates are used to launch virtual machines from predefined configuration. Think of an instance template as a description of the virtual machine. If you do not want to configure a virtual machine from scratch, you can use instance templates and launch them. And through instance templates, you can also configure the machine type, boot disk image, CPU, memory, and many such properties. A managed instance group is a collection of virtual machines that are identical in nature. The biggest advantage of using a managed instance group is that it comes with auto-scaling and auto-healing properties. What I mean by that is, if your cluster experiences heavy volume of traffic, managed instance groups can automatically grow the number of instances in the group and meet the demand. Also, let's say if for some reason a virtual machine stops or crashes, the managed instance group automatically recreates that virtual machine. With that information, let's go ahead and create a cluster of virtual machines. First step, let's create a simple script that installs the Nginx server during the initialization phase. All these commands are directly available to you on the Quick Labs page. Feel free to copy and paste them in your Cloud Shell environment directly. We'll now go ahead and create an instance template that uses this startup script. As the command suggests, I'm creating an instance template called Nginx template and I'm passing the startup script that we just created as well. Next, let's go ahead and create a startup pool. Now, a startup pool is used to create a single access point to all the instances in a group. With that, let's go ahead and create a managed instance group. Now, as you can see from the command, we are creating a managed instance group called as Nginx group. The base instance name is a prefix that will be applied to the name of each virtual machine. The size indicates the number of virtual machines. And finally, we provided the instance template and target pool details that we just created. All right, now that a managed instance group is ready, let's verify that virtual machines have been created. We'll use the gcloud compute instances list command to verify this. As you can see, we have two servers up and running. These two servers will now act as a backend to our load balancer. Let's quickly go ahead and set up a firewall rule as well to ensure port 80 is granted access. Give it a quick second for it to initialize and set up a firewall rule. All right, looks good. Now that our web servers are set up, it's time now to set up our load balancers. But before that, let's try and understand the basic difference between a network load balancer and a HTTP load balancer. A network load balancer is a regional load balancer that load balances traffic based on IP, port, and protocol. An HTTP load balancer, on the other hand, is a global load balancer and is used to serve HTTP or HTTPS traffic. The second difference is while a network load balancer can function on any port, HTTP load balancer uses port 80 and port 8080 for HTTP traffic and port 443 for HTTPS traffic. With that information, let's go ahead and launch a network load balancer by creating a forwarding rule. As you can see, we have created a forwarding rule called Nginx LB on port 80. Give it a quick second so that it can create a forwarding rule. All right. Now that it's created, let's take a look at the details using the gcloud compute forwarding rules list command. And there you go. Within a few minutes, you have successfully created a network load balancer. The IP address listed over here will act as the endpoint and will be used to access the application. Moving on to the final section of this lab, let's go ahead and create a HTTP load balancer. Now, there are multiple components involved in this. To grasp this better, let's try and understand what each component does and what the request flow would look like. Once your request reaches the load balancer, a forwarding rule comes into picture. The forwarding rule will send this request to a specific HTTP or HTTPS proxy depending on the IP address, IP protocol, and port specified. The HTTP proxy will then route this request to the URL map. The URL map knows which backend service to connect to based on the URL path. Finally, the backend service contains details of the managed instance group to which it needs to connect to. Let's go ahead and configure each and every component now to understand this better. First, let's create a health check. Health checks are important to ensure that your backend is up and running. As a next step, define the HTTP service and map a port name to the relevant port for the instance group. This will ensure that the load balancing service can forward traffic to the named port. As a next step, let's create a backend service. A backend service defines how cloud load balancing distributes traffic. What protocol to be used and what health checks to be performed are all listed over here. As you can see, the name of my backend service is Nginx backend, and the protocol that will be used to connect to the backend is HTTP. Next, let's go ahead and add the managed instance group that we created earlier as a backend. All right. Next, let's go ahead and add a URL map. Now, a URL map indicates which backend service to connect to based on the URL path. Now, using the URL map that you just created, go ahead and create an HTTP proxy. In case of HTTP load balancing, proxies route incoming requests to a URL map. Finally, create a global forwarding rule to handle and route incoming requests. All right, that looks good. Now let's go ahead and verify the details of the forwarding rule that we just created. With that, you have successfully configured and deployed a HTTP load balancer. And that marks the end of our last lab in Google Cloud Essentials Quest. Don't forget to go back to Quick Labs page and track your progress using the Check My Progress button present after the end of each section. You have done a phenomenal job. Good luck. Congratulations once again on completing the labs and getting your Google Cloud Essentials badge. It is now time to make your Quick Labs profile public and share your accomplishment with your network. First, navigate to My Learning on your Quick Labs profile. Next, in the upper right section, click View Public Profile. Next, in the Share Your Badges with a Public Profile dialog box, click Make Profile Public. Then, by right clicking on the Make Public Profile, you will get a shareable link to your public profile. Please feel free to share your profile with your social and professional network. Don't forget to use the hashtag Google Cloud Ready. Great job, everyone. We are so proud that you have made it this far. Share your achievement and don't forget to fill the quest completion form in order to get a chance to be accepted in the Google Cloud Career Readiness program. In order to verify that you have completed the Google Cloud Essentials quest, you need to submit a short form before the deadline mentioned in the email invitation you received earlier. After verifying your completion, we will send out the invitation to you for the Career Readiness program. Give yourself a huge round of applause for achieving this amazing feat. If you're stuck at any stage while completing the quest, there are a few ways you can get help immediately. The fastest way to find a resolution is through the online chat support that is available 24/7. You can also drop an email to support@quicklabs.com with your problem. Or just pick the third option and Google it. And that brings us to the end of the session. I hope you had fun and enjoyed this presentation. Congratulations once again, and all the best for your future.